The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to our audience for our National Road Safety Partnership Program webinar titled What Happens When Workers and Mobile Construction Plants Interact. This webinar is brought to you by the NRSPP in partnership with the Australian Road Research Board and Downer. And the NRSPP has been established to provide a collaborative network for Australian businesses and organisations to help them create a positive road safety culture, both internally and externally. And it aims to help organisations of all sizes across all sectors to share and build safety initiatives specific to their own workplace and beyond. It is delivered by ARB and funded by a government coalition and ARB. And people can actually log on and register to receive the newsletter if they want. Next slide, thanks. And Jerome Carslake, who manages the NRSPP, normally moderates the session, but today I'm standing in for him, and my name is Rosemary Patterson. Next slide, thanks. Today's webinar will go for approximately 45 minutes and 15 minutes for questions time throughout, and we'll be recording the session today and we'll share the recording. And we love to hear from our audience, so normally our audiences are pretty interactive, so we'd love to hear any comments or questions or anything. And next slide, thanks. Our presenter today is Paul Constanzo. Welcome, Paul.
G'day, welcome. And I appreciate being given the opportunity by the National Road Safety Program or Partnership Program to present today a little bit on what Downer is doing in the space of plant and pedestrian interface in particular.
Awesome. And Paul, yeah, just a little bit about you and how where your wisdom comes from. So you've got more than 18 years experience within the road resurfacing industry and more than 14 years delivering services in direct operational functions across product manufacturing, facility construction and service delivery. And it's awesome to have your wisdom here today, Paul. Thank you. Let's get started.
Yeah, thanks again, Rosemary. So I guess why we're here today and what am I here to talk about? So Downer as an organisation has been on a bit of a journey for the past 6 years, in particular understanding its critical risks that exists within its business. And the discussion today is really to talk about how we can potentially measure the impact of the change culturally that we're having within our business and whether or not there's some technology out there to assist us in measuring that impact of the policy change. A brief introduction on where we are today. Plant pedestrian interface, which is effectively people being in close proximity to plant, has been identified as one of the key critical risks within our organisation, in fact within the industry that we work within. We've done a lot over the past 6 years to identify the risk and assess its nature. I guess some of the things that are born out of that assessment of risk and building programs have been with the implementation of a range of different programs, some of those that I'll talk to today. What are we doing as an organisation to measure the impact that we've got on that policy change, on the cultural change and influencing behaviour, and how we're using technology to do that. So if I start with just a little bit of history, well, the graph that you see in front of you is effectively, you know, the number of observations that we did as an organisation that specifically related to reversing incidents. So in any organisation, typically, you know, you would run with lag indicators, so TRIFA, MTI, LTI, etc. And you can see that's pretty prevalent, that we were no different as a large organisation up until about 2011. Our lag indicators were trending pretty steady, I guess, as an organisation. But then you can see at the end of 2011, something happened. So if we look at the amount of incidents and injuries that we were having as an organisation, there was a fair few there. And you look at the fact that, you know, that lead style engagement with the business or lead style indicators and measuring and tracking those was fairly low, and we were still, you know, having a number of incidents. Unfortunately, unfortunately, in November 2011, we had a fatality. So I guess here we were as an organisation sitting back thinking, well, our traditional statistics, which were to measure our safety performance, we're tracking okay, we're tracking steady. So how did we get to the point where we are today that we'd had an incident and that incident had become a fatality? So I guess what we decided at that point is that we would begin to heavily look at lead indicators and some of the predictive nature of the lead indicators to understand whether or not we were really focused on the parts of the business and the risks that existed within the business that could cause this particular incident or issue. We began looking at high potential incidents, capturing them and reviewing them. And then as a direct result of that, we began influencing and building on CEO-driven safety data, which I'll talk more about in the next slide. But you can then see that the rolling average for the lead indicator engagements within the business substantially increased, and it had a direct correlation to a reduction in incidents within the business. So we knew we were on the right track, and we just wanted to make sure that we can continue to build on that and understand what additional things we could do to bolster that. And that's just some information about the changes in the stats. So the journey began. We embarked on change within the organisation. We started CEO-driven safety focus days, which were focused on linking the different parts of the business. We're no different as a large organisation. We have many moving parts. Sometimes those parts don't integrate or mesh as well as what they could. So the CEO drove the focus on identifying critical risks within the business, breaking down the silos between the divisions to arrive at a cross-functional solution. Distinct change from focusing on lag indicators and develop a system of generating lead indicators. In November of 2011, we implemented the first near-miss line in New South Wales, first within our business, then we followed that nationally. Our current near-miss system, which is predominantly focused on identifying lead indicators, logs in excess of 800 events per month across a range of different critical risks. So when we say 800 events, they're not just plant pedestrian, they're a whole range of critical risks that we've identified within the business. And those lead indicators then drive the focus areas. One of the other things that we did as well was we began the Mission Possible franchise. Franchise 1, which was focused on the plant pedestrian interface, which is what this presentation is about, had the tagline, "Safe position is my mission." It was focused on structured delivery of key messages that were simple, then putting these messages into practice in real time in practical demonstrations across the country. So we tried to stage the way that we develop an interface and engage with the business. What we did over the period of about 10 days is we had forums on average the size 500 plus people with around 30 pieces of plan at those forums, and the day was effectively split into two, which had a focus around delivery of the simple message and then the reinforcement of that simple message in real time, in real terms, on the plant that they would normally use or be engaged with on the day. Part of that Mission Possible focus as well was about the introduction of the technology that we were using to then support and measure the change. The Mission Possible approach was fairly simple. We had quite complex no-go zones, exclusion zones, and to be honest, they were causing confusion within the business. We introduced the red zone, which was simply no one could be 10 metres in the possible direction of travel. However, there were some exceptions to that rule. We also gave our business 3 distinct tips, and these were: the plant operator or any person operating a piece of plant needed to check to make sure that the red zone was clear. Do I need a spotter? Can I see the blind corner I'm about to enter? Am I potentially entering an area where pedestrians might be? Is there a person on foot? And if the person is on foot, well, from outside the red zone, the person on foot needs to establish positive contact with the plant operator, i.e. a wave, a nod, contact on the two-way radio, Make sure that they have seen you and understand that you want to access their red zone, and then do not approach the piece of plant until they disengage the item from operation, i.e. is the bucket down, is the engine revs down, or the hands off the control, etc. And then obviously the third tip, never assume. Communicate, communicate, communicate. Don't assume that just because that truck drove past you while you were standing there shoveling asphalt, that he remembers that you were still standing there. So that were the 3 simple tips that form part of the message. In terms of the way that it works, it's fairly simple. 10 metre separation between yourself and the piece of plant or asset in the possible direction of travel. The one that I've showed you up here is effectively a ute. So even if the ute is driving past you, you can't step behind it within 10 metres of it because it could potentially travel in that direction. Some complexities that were obviously quickly established within the business, and we had to walk and talk through those, were, as an example, for a paver, an asphalt paver, and some of you may not know what that is, but it's effectively a machine that's used to lay asphalt. Again, 10 metres in the possible direction of travel. So when that piece of equipment is travelling, it's 10 metres in both directions. However, when it's working, when it's engaged, it physically can't travel backwards because it's got material going through it. So the rear 10 metre zone disappears, which means people can work around the back of that machine in harmony. Another one which we had to clarify as part of the red zone discussion was how a skid steer or a forklift might work. And put simply, there's 2 distinct examples there. So if the machine is moving in and is travelling, it's 10 metres again in the possible direction of travel. Once the skid steer begins manoeuvring to work or complete works, it's pure and simple. It's 10 metres all the way around the outside of the machine. Now, as you can imagine, in many work sites where there is some congestion that exists, this is tough. But to credit to the team and to credit to the operational businesses, the businesses are doing really well with implementing this solution, and I guess we're seeing the benefits of that now, with people now suggesting that in some instances 10 metres can be extended. Any questions?
Yes, Paul, thank you. We have got a couple of questions. One is asking, what did you previously have in place? Was there a policy, or what was in place before this?
So prior to the implementation of the red zone, we had a range of different process and policy, which included exclusion zones and no-go zones, because depending on the application of work, at times you need to be able to work in close proximity to, let's say, the side of the machine. So the problem with that, though, is that it did cause some confusion across the business about what was an exclusion zone and what was a red zone. So in essence, we've now simplified the message to say that you effectively can't enter in front or behind a piece of operating equipment in its possible direction of travel. And then we've effectively generated a whole range of scenarios for most of the types of equipment that we have, which detail, the application of the red zone during travel, and then the application of the red zone whilst that machine is working, which might slightly vary as is shown by the example.
Awesome. And Mike asks, why choose 10 metres, not 8 metres or 12 metres?
Yeah, that's a very good question. I guess what we did, Mike, is that we generated this group of people effectively called the Baker's Dozen, where 13 people out of the entire roads business were selected from the operational business, so from the blue-collar workforce, to workshop, what would be the most appropriate distance to work to. And we felt that 10 metres was 10 metres is effectively 2 cars. It's sort of almost a profiler. There were some analogies that were made between easily being able to recognise, let's say, 10 metres as a distance versus 8 metres. Ultimately, we think, and we would like the distance to be 20 metres, but the distance needs to be workable, and we felt as a business that 10 metres was a good metric to use because people could, have some comparative or some comparisons to make sure that they could measure 10 metres. One of the activities that we did actually at the red zone was effectively that. show us how far 10 metres is, and then we provided some examples of what 10 metres would be. You know, it's two of these, or one of those, or it's that far. It's a good question.
Awesome. And that's exactly what Sean just asked. How did you get consistency on the 10 metres as a metric, not an estimate? So that's what you're saying. You gave some examples.
Yep, used some examples and then tested those examples through some of the games. And we called them the fun of the fair, but it was effectively, you know, how far is 10 metres, please drop? You know, this rope is 7 metres, how can you make it 10 metres? There was a range of activities that were done. And I guess people are pretty good at, you know, once you show them once or twice about sort of what 10 metres is. And we felt also that if we said 10 metres and they didn't quite get it right, they were only 9 or they were only 8, that's still better than saying it's 8 metres and they're only 5.
Right. Great. And Tim asks, what's the response if someone enters the red zone, alarm or vehicle stops?
So at the moment, I haven't spoken about what the technology is in terms of the way that this process has been applied. I'll get to that, and I'm sure that question will be answered as part of the next lot of questions.
Awesome. All right, let's move on. We've got heaps of questions, and we might get to some of them after we've moved through the technology. Thanks, Paul.
Yeah. So I guess what do we do as a business to try and showcase the support technology to support this message and this change in our business practice and process? So what we did is we showcased a few types of the technology that were available at the time as part of our Mission Possible. There was no silver bullet. That's the reality. Each type of technology, and some of those you'll see today, has its pros and cons. It was also important to let the business know as part of the Mission Possible franchise that we weren't just sitting back on our laurels and expecting them to do everything as part of this change, that we would do everything that we could within our power to see if there were things that we could provide to support decision making, to support risk reduction, and to support them. I also want to remind everyone on the call too that this was effectively almost a 3-year project. So, this is a very short summation, in very, not so much layman's terms, but a very short summation in very simplified terms to get it into the time. There is a substantial amount of information behind this that supports this. And if anybody's interested afterwards, I'm more than happy to, converse one-on-one via email if there's any other additional information that I could provide about, our experience in this space. And really, the presentation and the technology has been simplified for presentation purposes. In terms of the different types of technology, there's radar, which is very similar to sonar, and it's a broad zone detection system. It effectively generates almost like half circles or 3/4 circles, depending on the type of radar system you've got, around the sensor unit. Sonic, which is very much like your typical reverse parking sensors on a car, does a very similar thing, but uses sound waves. Vision systems use cameras and then have some type of inbuilt algorithm which then looks at what's happening in the picture and makes decisions based on what's happening within the picture. And a lot of these systems just use standard vision cameras, so a typical webcam or a camera you can pick up from your local store. RFID relies on another system being able to detect the sensor within a pre-delivered object. So, a small sensor either in a card, like a scanning card when you're into an office, or a sensor sewn into a vest or a pair of overalls or placed on a hard hat. What were the key focus areas for us when we looked at what support technology we could use to support the message? They were simple, right? This technology had to work in all types of weather conditions: hot weather, cold weather, steam, dusty and humid environments. It couldn't be impacted by prevailing wind conditions or reflective surfaces, which are, as you would expect, in the range of conditions that we all operate within this industry. At some point in time, you're impacted by all of those things. We also want to make sure that the technology is infinitely configurable and it has a number of different detection states. So rather than just a detection state or a beam that gets broken like in the very old school technology, we want to be able to actually understand more about what it's just detected. So, what's the object? What's the distance it's travelling? Does that object have high visibility clothing on or not? Is it human? Is it a machine? How far is it now? How about now? Et cetera, et cetera, et cetera. All those types of things. We also want it to have ultimately or infinitely configurable detection zones. So within your field of influence or your field of detection, you want to be able to do different things depending on where it is in that field of detection, not just simply, okay, once you're in that field of detection, which might be 4 metres by 5 metres, it just detects it and that's it. The technology that we wanted to do also wanted to have the ability to be able to record, log and report on the incursions and the type of incursions. This is a very important part because this information would then be used to report on a global level about the effectiveness of your policy on impacting change within the business, especially from a cultural perspective where you're asking people to behave differently and make different decisions. This thing should be able to track all that information and capture it. And then obviously the system itself, you want it to be digital interfacing. And the reason for that is that you want it to be able to communicate with OBD ports on OEM delivered vehicles or CAN bus systems on pieces of plant, because at some point you want to be able to talk to the OEM engine management system and influence the machine's behaviour. If we start with just radar and LiDAR, most of the technology that you look at that is associated with plant pedestrian interface is sort of split into two sections. Section one is what is the sensor that you're using, and I've just listed off all the different types of sensors there are that does the physical detection, and section two then is what do you do once you have a detection with that information. So there's two key sections. We'll start with section one. If we start with physical detection, if we look at just radar and LiDAR, the picture in the top left-hand corner shows an atypical radar system. The one at the bottom shows the LiDAR system. They work in much the same fashion in that they effectively create a field. There's a picture on the right-hand side which shows the field that they create. That field, simply because of the nature of the technology, is very difficult to control. So as an example, if you look on the top right-hand side there, you would always detect an object at a certain distance running beside that first object. Now, the problem with that is if you're working in an environment that requires pieces of plant to work in close proximity or plant and people to work in close proximity, that can be a problem because it can create false positives. In terms of some of the pros, it's a very low-cost sensor. It's established and tested and well-implemented technology in a range of different industries. Some of the cons, you have a lot of difficulty in shaping the detection zone. It can't differentiate between objects, i.e. it either detects something's in there or it's not. And it can be heavily influenced by certain climatic conditions and the reflectiveness of its surroundings. And it often generates false positives on the detection extreme zone. So you'll see the differences in the colour of the fields in that picture in the right-hand side. That's effectively detailing down to a level of accuracy that you're getting with each detection type. So it can be a problem. Sonic and sonar, it's very similar. It's the same technology that's used on reverse sensors on cars and trucks, etc. It similarly displays similar half circle zones around each sensor, which then activate when an incursion happens. The pros and cons, like I said before, are very similar to radar and LiDAR. You can see that they've been installed in the top left-hand picture. They're almost like your standard reverse parking sensors that you would get, so little black dots on a car, and then they would just detect at a certain zone or a distance. The picture on the right-hand side shows the two sensors on the arms of the rear of the grader. The circle at the top just shows that that's a reverse camera. That's all that shows. The vision system. A vision system uses computer interpretation of what it sees to establish the risk. It's normally a very complex system that has a camera system and then would need normally a large PC-based style system. This one that you see up here, which reminds me of the movie Short Circuit, number 5 is alive, as you can see. It's a system that we trialled some time ago and is a very complex system. Some of its pros is it can distinguish between objects in very close range, so 0 to 5 metres. So if you look at the pictures on the right-hand side, in a warehousing application, it's quite good in understanding between 0 to 5 metres. Well, hang on, that's pallet racking. That's not a person. and you can see that it's not setting the sensor off in the top picture. However, in the picture directly below that, it then recognises the difference between what a pallet rack looked like and something that might resemble a human. The problem with these types of things, I guess, from a cons perspective, and most of the vision systems are like this. This is just one variant of the vision system. They require very large desktop PC, required space on board the machine to mount the brain to control the algorithm. It has lots of trouble during certain climatic conditions and generating false positives. So if you're going from day to night or night to day, or the lighting is transitioning, or there is steam, or there is dust, it has problems. It must be tuned to either work in certain conditions, so you can really only tune it to work in either day or either night. And then again, it requires additional architecture normally for night function. At a distance of greater than about 5 metres, it has, its accuracy really drops off in its ability to be able to distinguish between objects. So it can do the usual thing and detect that something is there, but if you're asking for it to distinguish between objects, it really struggles with doing that. And it can only detect pedestrians. Most of them can only really detect pedestrians, if they're wearing high-vis clothing. If they're not wearing high-vis clothing, the system struggles. It's also a very expensive unit, and it has very high installation costs. RFID style systems. Again, the hardware associated with these types of things is there needs to be a sensor mounted on the machine somewhere, and it generates a round field. You would then sew tags either into cards or into clothing or onto items, which then could be picked up by the sensor. The top left-hand picture shows that effectively a single sensor receiver, and it generates a circle, a pure circle around that asset. You can see that the picture on the left shows a pink zone or a reddish zone and then a green zone. So it'll only pick up RFID tags or sensors within that pink zone. Outside of that, it doesn't pick them up. The picture on the top right-hand side shows what you can do with a multi-sensor, which to increase the zone. Some of the pros, it's excellent. These types of systems are excellent. We've got highly controlled work environments. So, mine sites, quarries, where the risk of someone potentially entering an area without an RFID tag, either on a vest or on a hat, is either mitigated or non-existent. These sensors or these systems work really, really, really well, right? Because as long as the person has one of those inducted style sensors on, it'll always be picked up. The units are very low cost, and the tags themselves are very low cost because they're in high circulation. There are plenty of mine sites, plenty of quarries around the country, across, or even internationally, that use this style of system to, assist with pedestrian detection. Some of the cons, it's very difficult and costly to shape the detection zone. So when you're trying to provide a solution that has the ability to be able to shape the detection zone, it's very high cost to do it with these types of systems. It will not detect anything that doesn't have an RFID tag, so a fixed object or someone that's on site that doesn't have one, it will not detect them. It has some higher administration and management costs because it requires all of the assets that have the sensors and all of the tags themselves to go through an induction process. And it cannot differentiate between objects, so it'll just detect the tag and that's it. It also cannot detect if an incorrect induction process has been facilitated. So if you have an RFID tag that says that this object is X high by X wide, and someone has filled that in incorrectly, the sensor will only pick up what's on the tag. So if the machine is actually larger and longer, it won't pick that up, and then you could have an incursion as a result. And it also needs the sensor themselves also needs a minimum vehicle detection size. So you've had a detection, now what? So what we want to do, and I guess this is one of the challenges that Downer is facing about what do we do with this information. So regardless of the detection type used, what do you do once there's been a detection? All of the technologies listed today have the potential to generate an output of, some better than others, whilst being mindful of overstimulation. So what you don't want to have is a whole range of false positives and on-site alarms. And you also don't want to just add potentially another type of reverse alarm or horn or sensor to a site that already has a number of those same similar things on site, because it'll just overstimulate people on site, and then effectively eventually they'll ignore it. You want to make sure that the notification is targeted and that it's really only focused on the people that are at risk, so the operator of the plant and the people on the ground. You want to make sure that the outputs of the detection can be digital or analog, and you want to make sure that the outputs can either be in the on and off range or in a range. So for us, going forward, we want the ability to be able to influence a machine's behaviour, adjust its power, apply the brake experience or stop, all those types of things. So this is the technology that we're focusing on. Our system is a bit of a hybrid system. So what are we doing today? It's been developed in conjunction with a worldwide manufacturer that it actually combines a few different technology types. The system is being driven to be low hardware and replication costs, try and utilise hardware that's already in use in alternate industries, so that hardware is obviously tried and tested. The system itself needs to be algorithm-based, right? So that way, as we as an organisation mature and our understanding of risk matures, our algorithm can mature as well and become smarter. So the system has to have the capability to be perpetually upgradable, almost like an iPhone, where you can just upgrade this, the operating system or the algorithm that's performing the task to deliver a better result. We want the system to log events in real time and to report on them in real time. And then we want the system, and we have the system that can collect information and store it in the cloud for real-time dashboarding and analytics. So this is what our system does. The picture on the left-hand side shows 3D mapping. So it has the ability to create a 3D map of any environment live in real time. That map can be configured and to any type and size of resolution. It has the ability to distinguish between objects and people. It has the ability to read street signs and traffic lights and interpret them. It has the ability to generate unlimited zones within the field of view and have different criteria established for each zone. So you'll see the picture on the right-hand side. That's an example of the zoning that we've established for our trial units, where you've got effectively the red zone immediately in front and behind the asset. And then beside that, we've got an amber zone or a pre-warning zone, then a yellow zone, and then effectively the green zone where we don't want any detection whatsoever. I'll show you what the system actually does. This is a video in real time of what our system sees. Before I start the video, I'll just point a few things out. There's 3 different views of what the sensor is seeing, because that's in effect what the sensor is seeing in 3 different fields of view. One's infrared, one's a multi-range, and one's a vision style. If you have a look, the person that's standing immediately in front, walking towards us now, they're in red, and they've got some numbers on them. So that's the detection of their distance. The red box, and you'll see that his colour changes to orange, and then it'll effectively change to green, and then go out of view, that's the algorithm assigning a risk level to that particular individual. The person that hasn't moved still has the same risk level, has the same distances of where he is. You can see around the field of view that it's also picked up some stationary objects that it feels that are in its risk zone, as dictated by the grid lines that are on the ground, which is effectively the red zone. So this thing works in live time, in all conditions, and you can see that both people have left the field of view and their risk zone has effectively changed with them. So this is what our system sees. That's just a demonstration still, just in case my video didn't work, and it worked well, so we don't need to touch on that. What's important about that entire thing is that we've got the ability to generate different zones within that field of view and pre-configure that view to match asset types and asset classes. The picture on the top shows the 2 sensors that are being used. Those 2 sensors there effectively generate that picture that you saw. Those 2 units are mounted to one singular machine. And this is, I think, is version 4 of our system. I'm expecting version 5, effectively the sensors to be in one sensor, the size of one of those. Those sensors now can currently feed the style and the types of incursions that we're getting across the business on these trial units in real time via SIM card up into a web-based iCloud portal, which is the picture, a snapshot of the picture that you see at the bottom there, which is showing one of the particular assets and all of the different things that it's picking up. Granted, at the moment, we're just focused on collecting information and the system has only been really in live trial in its current form for a few weeks, so we're still continuing to work through this process. And the results to date have been very exciting around the accuracy, the building of the fields, and then the accuracy of the collection of information that we're getting. What's important too is that then we can then use that information to then dashboard the performance of the incursions that we're having across the business to help the business manage where they might have problem areas within their functional delivery stream, or where we need to do additional work engaging with the business to understand why culturally we're not seeing the behavioural change that we want to see. And I guess that's what the intention of this process is. What's next? I guess continual refinement of the algorithm as we understand more about the system and its limitations. Continual reduction in the size of the hardware and making the hardware as low of cost as possible. We've also got something exciting happening where shortly we'll be able to have a live feed come back through the sensors. So if we're getting an incursion, we're hopeful that we can then track or have that incursion, take a picture of that incursion and have that fed also with the incursion information up into the cloud so we can get a live view of what's just happened. And then stage 4 of this concept hopefully towards the end of next year will be looking at how we can then begin machine control trials. So once we're comfortable that the information that we're collecting, we're mitigating any false positives, which will then impact its ability to control machinery effectively, and we're comfortable that that's all working, that we'll then begin looking at, okay, well, at 5 metres, I want the machine to cut to half power. At 3 metres, I want the emergency stop brakes to be applied to the machine to bring the machine to a stop. They're the sorts of things that will be the next step. Now, because the technology is all digital, it can interface with CAN bus and we can do all those sorts of things. So I guess that's a pretty exciting time for us. And any questions on any of that?
Awesome. Thank you, Paul. So we've got from Paul, are you getting data of zone intrusion? Are they decreasing? I think that's about the 3D mapping.
Yeah, so we are collecting data about zone intrusions, and I guess the focus currently has really just been making sure that the validity of the incursions is correct first. And so at the moment, I have the system effectively operating in silent mode. There are no alarms, there are no anything. The guys know the units are there and what they're for, but they don't make any noise, they don't interface with the machine, they don't do anything other than track what's happening on the site. And we purposefully have done that so that we can first check the validity of the data that's coming in. And I've got to be honest, it's very exciting because the data that's coming in is substantially accurate. So the next stage will then be what we're going to do in that space around, well, how we're going to engage and interface with the people at risk, so the people on the ground and the people operating the machine, and find the best way to do that, whether it be an alarm or something on board the machine, and maybe something visually to the operator or the person on the ground, and then use that as the next stage of cultural influence.
Fantastic. And Jason's asked a very tricky question about cost. What is the expected cost of running the system?
Yeah, look, I'm not going to delve into too much detail around, obviously, the costs associated with these systems, but I'll just say this, in that I would suggest that most of the systems that are on the market you know, currently running in plant pedestrian interface style where there's a piece of technology that's required. And if you look at simply the costs associated with implementing the technology and doing the work around the smarts behind this, so if you forget all the R&D costs, I'm estimating that we're going to be at somewhere about 30% below or 30% off current market costs for those similar types of technologies that are on the market. So they're very cheap. It's very cheap. The intention of this project was to be able to deliver it to get to a scale where it could be implemented. And I guess from Downer's perspective is that we're excited about talking about this to industry because we also think that once it's right, we think that we should be releasing this to industry so that everybody can use it. That's the intention.
That's fantastic. And Hugh and Emma asking a similar question. How many and what types of sites have you trialled it on? Have you trialled it in warehouse environments or outside areas only?
So a lot of the initial testing that we did to generate the algorithm to begin with was in warehousings, forklift styles, interfacing. We had to do substantial refinement though once we got it out into the real world environment where there's external influences like changing light conditions and all those sorts of bits and pieces. So at the moment it's in live trials currently in an asphalt resurfacing crew and in a sprayed seal resurfacing crew. So these are crews that, if you can imagine, travel a certain distance to a job site, which might be a council road or it might be a large project for a big customer like Abbey Group or Lend-Lease or whatever, and facilitates work in a closed environment and then moves on to the next site. So that's the style and type of environments being exposed to at the moment. And one of the machines itself as well actually vibrates a lot because that was the intention. We're trying to understand what the limit of the technology is before we begin to influence the incursions. So.
Awesome. And Chris was wondering, has Downer thought of collaborating with other large organisations to spread costs and also share systems across industry?
Yeah, I think that really goes hand in hand to the commentary that we made before. I guess, as an organisation, we saw an opportunity, and to be honest, we were quite lucky that we saw an opportunity to do something in this space, which was born out of a need from a fatality that happened in 2011. So in reality, in the background, these things have been bubbling away for sort of 5 or 6 years. So it was really, we didn't think it was pertinent to bring what we were doing and what we were doing to industry until we reached a point where we thought it had some value. And I guess we've sort of reached that point now. So, I'm more than happy if there's anyone wants to, catch up with myself and the Zero Harm team within the Downer space to see whether or not there's an opportunity to do some further cross-collaboration, because the reality is that we think industry should own this solution, not Downer.
Awesome. And this is the sort of sharing and leadership that is at the heart of what NRSPP is all about. Our partners recognise that safety is not a competitive advantage, but a share as their approaches can be applied elsewhere and save lives in the workplace. So we've got a couple of questions that came in earlier, so forgive me, Paul, if you've already answered them, but I'll just touch base with a few. So Mike asked, what is the range of RFID and will it handle 10 metres?
You can get RFID to go out to an infinite range if I'm totally honest, because RFID is effectively just it's a generation of a field which can be amplified. So, smaller RFID style systems will do 3 metres, 5 metres, 10 metres, but you can go out to 20 metres, 50 metres, and it all depends on your application, and then that obviously then directly impacts the cost.
And Omar was wondering what you thought about the possibility of integrating the two technologies, both vision and FRID.
Yeah, okay, so I guess from my perspective, if this was a question from the earlier section, I understand that because I hadn't spoken about what Downer was doing. So was this a question from the first question break, Rosemary?
Yes, sorry, my mistake. I've probably asked something.
Okay. I'm pretty comfortable that Omar will understand what it is we're doing now. So.
Okay, and earlier Chris asked, why was there no side clearance to a paver?
Sorry, why was there no, what was that?
Why was there no side clearance to a paver, for example?
Oh, because depending on the circumstances of the site, you may not have the clearance available. And I guess from a risk perspective, if you look at simply what a paver is, it's very different to a bobcat or a skid steer, some people know it, or a forklift. So a bobcat or a skid steer or a forklift can effectively turn on themselves. So within their own footprint, they can turn. And there's been plenty of examples where people standing beside those types of equipment working, let's say 1.5 meters or 2 meters away, have in fact been impacted because the operator, because of the vision on the machine or distraction or for whatever the reason is, effectively turns the machine on itself and can contact the individual. So any of those machines that we felt could perform that action have ended up with a 10-meter effectively, red zone right around the outside of them. And I showed you an example of that with the skid steer, which also applies to forklifts, but you can also apply the same thing to the boom on an excavator. I guess with a paver specifically, a paver can't do that in essence. When it's travelling forward and reverse, it's very difficult for it to turn on itself. And so from our perspective, we didn't see that as a substantial risk. So it was really the focus on, well, what are the things that can do that? Let's get those ones under control first. And then as we mature as an organisation, ultimately we want to make sure that we don't have anyone standing near any piece of plant in any direction. So I guess we need to take baby steps first.
And David asked fairly early on whether you'd used technology to implement and support the change. And I love the idea of the flip cards and the fact that you sort of got information out to people on flip cards and held seminars and things like that. But did you use any technology at all?
Yeah, I guess we did. We started looking at additional trials of all sorts of things. So what we did was we showcased the technology that was already being trialled within the business. So when the business came and saw our Mission Possible base, some people had seen some of the technology that had been trialled within the business because it was trialled within their parts of the business. And then I guess we're also using the development of, as I said, this is version 4 of this particular vision. This has continued since the franchise began, and people see that out in the field as we speak. So we continue to use technology to assist us with rolling out. And I guess this is one of the key parts, is getting this right so then we can accurately track what's happening so that we can then continue to, see whether or not we can impact culture with, policy change.
Awesome.
I hope that answers your question.
Yes, if that's not answered, let us know. And Alan asks how your system might relate to the RMS worker on foot system.
If I'm going to be openly honest, I don't have a lot of detail about the RMS worker on foot system. So I can only assume that it was probably one of the types of technologies that I mentioned earlier. I was at pains to not mention brands or profiles or businesses because I thought I didn't feel that was relevant to do that. But as an example, there would probably be 10 or 15 organisations experimenting in each of those categories that I spoke about at the very beginning. But as I said at the start, this is a summarised version of the review of all those different types of techs. And to be honest, it's not the RMS person on foot system is not front of mind of me, so I can't provide any comment. Apologies on that.
No worries, thank you. And Rod asks, all of the sensors are on the machine. How do you account for large loads? Shouldn't the exclusion zone be for the load, not the machine?
Sorry, I didn't understand the question.
So
Can you reread the question again, sorry?
Yep. All of the sensors are on the machine. How do you account for large loads? Shouldn't the exclusion zone be for the load, not the machine? So Rod's assuming that some loads hang out over the machine.
Oh, okay. So the intention is that the sensor, whatever it's attached to, is configurable to that machine or sensor or whatever it's on. So the idea is with the red zone, if a machine is, and I'll take a roller for argument's sake, if a machine is 2.5 metres wide, then the expectation is the detection zone behind that machine might be 2.6. You might have an extra 50 mil on either side of the machine. If it's 2.6 metres wide, directly behind in a 10 metre square. So if I go back to that picture from before, you can see there that it's effectively the size of the machine. If you have an oversized load, you can configure for that load width if it needs to be 3 metres or 2.7 or whatever the width needs to be. The thing is ultimately configurable. What's important though is that you can draw that box. And I guess that was what was important for us, because we were taking the approach of you can't be in that space. Now, although that's what we have done with this technology, there is nothing stopping you from effectively drawing any shape that you would like within that resolution zone. It's quite extraordinary how the picture on the left probably shows it. You can see lots of little squares. You can effectively configure every one of those little squares in 3D in that entire field. So just picture a whole heap of dots that match that. You can draw any shape within that and have a detection zone or field within that shape. So it's, it's streets ahead of anything that's out there in the market at the moment. I've got to be honest.
Jason has sent in just a comment from within the Downer DM Roads Queensland business. We have seen a substantial cultural shift and awareness since the Red Zone Mission Impossible rollout of workers positioning on site around plant, enhancing the safety of our teams on site. So that's awesome.
Good, thank you. It's good to hear that we're seeing an impact, and culturally people are seeing the change. That's effectively all we want is everyone to go home safe. That's all we all want.
Fantastic. We've got time for another couple of questions. Are you right to take a few more, Paul, then we'll finish up?
Yep, awesome.
Luther has asked, in a construction environment, there are lots of noises from various machines. How can the operator differentiate the warning from these systems?
Yeah, that's a very, very good question. I touched on it early on about breaking the technology into two pieces, one being the technology question itself and the detection question itself, and then the second one being, well, what do you do with that information and how do you alert the people most at risk? And usually the people most at risk are the operator of that piece of plant and then the person on foot that's in the way. And I guess that's a very valid question, because I often go out on the job sites and hear all sorts of different style and type of alarms from different types of equipment. And you just wonder how much people become desensitized to the fact that they've got all these things going on all the time, and how do you deal to that? I guess we don't, there's no silver bullet or there's no one answer in that regard. I guess some of the things that we're looking at are things like vocoders. So in Europe, it's quite common for them to use, human voice notification. So you might have a male or a female actually tell you about the warning or tell you about the issue or the risk. It's not uncommon to be in the UK, and if you're standing too close to the footpath and a garbage truck pulls up beside you, and let's say he's going to turn left at the traffic lights you're standing at, it's not uncommon for you to be detected by the garbage truck, and the garbage truck to tell you to step back from the curb because you're too close to it. So that's not uncommon. And I would suggest that Australia will begin to migrate to those styles and types of technology. But I'm in the same boat as you. I'm a bit concerned that with having just another alarm, just another beeper, just another siren, just another horn, we're already overstimulating people on the job site. So it's really about what's the best way to engage with them directly. And I guess we're looking at a range of different things, whether it be audible or visual.
And you might have already answered this one, Paul, but Karen has asked, can the system make allowance for a spotter in the vicinity of the plant?
Well, it can certainly detect that there'll be a person standing there, so it can do that. As I said at the start, the system is ultimately configurable. So as long as you can change the detection and differentiate that particular person from, let's say, someone else, and you might do that by having them have a different colour high-vis vest, for argument's sake, right, a pink one or something. The system would then be able to detect, well, that's a pink one, that person's a spotter, and you've told me that for a spotter, these are the things you want me to do. So the system can do that, yes.
Fantastic. And thank you for all the wonderful questions that have come through. And it's been great, Paul, for you to present your approach, which is really underpinned by the never assume and the KISS philosophy, and just making behavioural change that way. And it's really powerful. Do you have a take-home message?
Yeah, look, I guess from a perspective of Downer, the tagline that we had within our business, within Mission Possible, was safe position is my mission. So the idea was that the business and the individual was ultimately accountable, for their behaviour and that their behaviour could influence the outcome in every single scenario. So I guess that whilst, one of the takeouts that I take out from this and that we convey as part of our message to the business, these tools are fantastic. Technology is fantastic, but it's only ever used as an aid. People really need to be aware of their surroundings and understand the risks and the dangers that they work within. And because that's ultimately the way that people will make sure that they don't end up in a situation where we're having to rely potentially on technology, intervening to keep them safe. So whilst these tools, all this technology stuff, it's all really good. It's really only a tool and an aid, and in essence, it's no more than a seatbelt light in a car. So just remember that there's no single panacea, and the technology is coming forward, but people need to make sure that they themselves are aware of they have high situational awareness and they're aware of their environments. If people can take something away from that, that'd be fantastic.
Fantastic, thank you. And just while we're looking at that slide, I'll let people know we have another NSPP webinar coming up called Keeping Safe Around Vehicles. So check the website for that. And Paul, Andrew has asked, can we get in touch with Paul if we have further issues? So I wondered if we could finish off with your contact slide, which is probably right back at the beginning. And Peter said that it was great and he will spread the word, but he had to log off.
Okay, well, there you go, guys. I've put my email address up there and my phone number. As you can imagine, we field all sorts of requests and inquiries, and we're more than happy to do that. And I guess we've got a little committee that we run here within our organisation, which is focused on making sure that we as an organisation focus on the initiatives that are important to both the business but also to wider industry. So I'm more than happy if people want to reach out either through this way or through LinkedIn. And I can provide any sort of information that I can. Make that mistake during, I won't be able to provide everything because obviously some things will be commercially sensitive. But having said that, I think that this solution needs to be owned by industry, not by Downer.
Fantastic, and thank you so much. You probably prefer email, would you, Paul? Because then you can get back in your own time.
Yes, please.
Awesome. Paul, thank you so much for your time preparing this and delivering it. It was just fantastic to have you today. And we'd like to thank the audience who've been great with their questions and kept the questions coming in. Please take 2 minutes of your time to fill out the survey that will launch shortly. Thanks so much, Paul.
Thanks, Rosemary.